Hi, and thank you for clicking on this video. Today, we will discuss how incense sticks affect your health. Incense is often used in residential homes, where it represents one of the most significant sources of combustion-derived particulate matter in indoor air. In this video, we will answer the questions: how does incense affect the particulate matter concentration? And how does ventilation affect this concentration? And what does this mean for your health? To answer these questions, we will first show you the experiment we created, then we will discuss the results, and eventually compare this with the particulate matter limits set by the Dutch government.
Start with the setup of the experiment. For the setup of the two control experiments, we measured the background concentrations in a 43 cubed room with a closed window. By doing so, we created a box model. We placed the Dita counter in the middle of the room. The time in between the measurements can differ a bit since we wrote the measurements down by hand. We tried to be consistent by writing down every 2 to 5 seconds the number of particles larger than 0.5 micrometers as displayed on the Dita counter. We did this for a period of 10 minutes for each different experiment. For the setup of the second control experiment, we opened the window and then measured the background concentrations. For the setup of the first real experiment, we closed the window again and waited for 10 minutes until the Dita counter was showing similar measurements as compared to the first experiment. For this experiment, we placed the incense stick in the holder on approximately 1 meter distance from the Dita counter. We lit the incense stick and then blew it out to create smoke. Right after, we started with the measurements. For the setup of the second experiment, we lit the second incense stick and measured again. For the setup of the third experiment, we opened the window again and measured again the number of particles larger than 0.5 micrometers.
After obtaining the measurements, they were first converted from 0.01 particles per cubic feet to particles per cubic meter before being plotted in an XY plot. The two controls both had a trendline slope equation displayed on the graph that is essentially zero, meaning that therefore any change in the PM 2.5 particle count is assumed to be from the incense stick or other factors. After removing the background particle count found in the average control experiment from the experimental measurements, the results of the three experiments are plotted in the figure shown. Measurements are spread out over a range of values, as the smoke hitting the Dita counter is not at a constant rate. However, it's still possible to observe trends in the data. Experiment 1 and 2 both saw a positive correlation over the course of the 10 minutes, with Experiment 1 experiencing a larger increase than Experiment 2. Experiment 3, on the other hand, experiences a negative correlation.
And now I will talk about the experiment results in more detail and compare the observed values. In the second table you can see the results for the experiment with one incense stick. As you can see, the concentration for this experiment is higher than the one for the control experiment. It increases by 97.4%. This large increase is due to an emission source that appears in the room. Besides, there is no ventilation, which restricts air exchange and mixing with the clean air from the outside. This is a table for the experiment with two incense sticks. When the second incense stick is added and the window is closed, we can see a further increase in the average particulate matter concentration. When comparing the experiment with one incense stick and a closed window with this experiment, we notice that the particulate matter concentrations increase by 19.1%. When the window is open, the average particulate matter concentration increases by 8.2%. This is not what we expected. In the control experiment, we saw that the average particulate matter concentration decreases when the window is opened. We expected to see the same pattern here. One possible explanation for this is that we may not have measured long enough to see this expected decrease. If the air in the room is well mixed with the air from the outside, we should see a decrease in the particulate matter concentration. To find out if the observed value is an error or not, we should repeat this experiment for a longer period of time.
What do these values mean for your health? The back of the Dita counter provides a chart listing the quality of the air based on the number of particulate matter. While the control measurements fall under the range of fair, all experiments that take place are well beyond the very poor range. And how do these values compare with the PM 2.5 emission standards set by the Netherlands? To compare, we first must convert our PM 2.5 values from particles per cubic meter to micrograms per cubic meter. We found, based on a study, that the average density of incense aerosols is 1,100 kilograms per cubic meter. Since the dye loss counter was placed close to the incense sticks, the majority of particles would be in the smaller size range, and the size distribution we chose is in the figure on the left. Based on these values, we could compare the average values of each experiment to the emission standards set by the Netherlands. Using the formula listed in the top of the slide, we found the following average concentrations. While both controls saw a concentration that is well below the emission standard of 25 micrograms per cubic meter for a 24-hour period and 10 micrograms per cubic meter per year, all three experiments were well above the emission standards. When the measurements were taken, the incense smoke was directed towards the dye loss counter, essentially picking up the incense smoke before it mixes with the air in the room, which is why the experimental values are so high. Therefore, comparisons between the two are not very reliable in that our measurements don't provide the full picture of the change in concentration in a room over time. The most conclusive statement that we can make at the moment is that breathing in pure incense smoke is definitely not good for your health.
Well, that's not a surprise. So, in short, the experiment showed that the incense smoke increases the PM 2.5 concentration, and by ventilation, this concentration would then decrease. Further research, such as a longer measurement time and more samples, will provide a more concise and reliable answer to our research questions on how PM 2.5 concentrations change in time. However, one thing is clear. All PM 2.5 concentrations measured in all three experiments is definitely not good for your health, and proper ventilation is key. Don't directly breathe in incense smoke. It will burn your throat and sting your eyes. Trust us.